This video presents a brief introduction of Info Framework, a statistical framework for experimentation and rapid prototyping. Info Framework is designed as modality domain and language independent and can be used, for example, in discourse analysis, forensics, sociolinguistics, in computer games. The framework implements means for evaluation, fusion, optimization based on the Vector toolkit, as well as creates sample prototypes that can be reviewed. The framework is implemented in Java and Jython and was tested on the Emotext for long text. In summary, the framework processes a corpus and creates statistical datasets. Using vector classifiers, these datasets can be evaluated, fused, optimized, or defined for creation of NetBeans software projects with Java sources. In this introduction, we use an emotional corpus with text of 215 movie reviews annotated with 9 classes, from 0 stars to 4 stars in increment half star. An example of such movie review can be a review of the movie Wrestler on the realviews.net webpage annotated with stars. The framework is controlled by a graphical user interface containing 5 tabs, corresponding to 4 different processing steps of datasets and their prototype creation. Preferences concerning processing steps, such as pre-processing of feature groups, already loaded. In the first generation step, the framework processes text of corpus and composes statistical datasets. The classified corpus is pre-processed. Groups of extracted features, here feature grouped words, are extracted and evaluated relying on custom feature classes developed in Python. The generate button starts pre-processing, in this case calculates the frequency list of the corpus that contains words ordered by their frequency in the corpus and composes a lexical dataset. Generation of the dataset is finished and the generated dataset file is stored in the directory specified in the preferences, here the freq directory. In this video, we generate dataset that extracts 10 lexical features, 10 most frequent words of the corpus, or 1,500th part of the frequency list. The next step is evaluation of the generated dataset in the Evaluation tab. The Evaluation tab controls statistical evaluation of the generated datasets. It specifies the used classifier from the Vector toolkit, for example, sequential minimal optimization, SMO in Vector. The evaluated datasets can be defined in the list directories of files to evaluate. There are also other parameters that can be used for evaluation of datasets, such as the name of the cosmetics file. The Evaluate button starts evaluation. The evaluation is finished. It calculates conventional measures as recall and precision values averaged over classes, here values of R and P columns, about 20% and about 19% correspondingly, and other measures described elsewhere. The tooltip shows the confusion matrix of the evaluated dataset. The evaluated dataset can be optimized in the Optimization tab that shows, among other fields, the utilized classifier from the Vector toolkit and the directory to store the dataset in the field storage directory. In the list directories of files to optimize. You see the file we generated before and that we will optimize. The FFS button starts the forward feature selection optimization procedure and calculates the optimized measures. The optimization table shows current optimization results in the corresponding columns. The original recall value in the OM column. The OPM column shows the optimized value. The optimization improvement is specified in the plus column. Optimization is finished. The original value, about 20%, is optimized to the value of about 21%. The optimization improvement is about 1%. The tooltip shows indices of the features of the original dataset that were extracted in the optimized dataset. Generated datasets can be fused. The Fusion tab specifies the used classifier from the vector toolkit. The Fusion result can be stored in the directory specified in the field storage directory. In the list directories of files to fuse, you see besides the file we generated before, also another dataset containing grammatical features generated before for the purpose of this introduction. In this video, we will show only Fusion at the feature level as the most trivial Fusion case. Clicking the Start Fusion button starts Fusion. The Fusion is finished. The Fusion table shows the results of Fusion. In this example, the recall value about 12% and the precision value about 4%. The tooltip shows the participating datasets and the confusion matrix of the fused dataset. In the final step, the prototype is created. In the current framework, a prototype is a Java classification servlet such as a emotext. In future, a prototype will be based on other software paradigms such as a dialog system or multi-agent system. To create a prototype, a developer defines a vector classifier that will be used in the new classification program, the root directory for the composed NetBeans project and Java sources, the prototype name, the datasets the prototype will rely on. In this video, the demonstration prototype uses 4 datasets. The lexical dataset we have just created and 3 datasets created before for the purpose of this introduction. A stalometric dataset, a grammatical dataset, a deictic dataset. The Generate Prototype button creates a Java prototype servlet. The prototype creation is finished. Now you can review the prototype. This can be accomplished by clicking the Review Prototype button. This will compile the Java sources of your prototype, start an internet browser, and show the prototype just created by the framework. Afterwards, you can adjust the prototype in your favorite Java developer environment, for example NetBeans. Thanks for your attention.